So let's look at the setup function. Because we have a very massive complex model right here, so even the setup function to be very lengthy. In this video, we're only going to look at the first section of it. So the first two lines are very easy. Wipe out the world, push the clock back to 0, and then here are some commented out code. This code actually part of the Go procedure, as we can see right here. The scenarios, first of all, defined in the globals, and then inside the Go procedure, we have different scenarios, because dealing with housing markets, we needed to experiment with different scenarios, different situations, how the market would react. And right now we only is trying the rate fall scenario. There are other 3 scenarios to experiment with. So this is about scenario. And now we can define other, we can initialize the other global values. For example, initial vacancy rates, how many of the houses are empty. At the very beginning, we set it to be 5%. How many realtors in the market, we set it to be 6. Maximum homeless period for each household. This is a global variable, not defined inside of the code, but defined in the interface right here. So we will not find this in the code section, but can be found in the interface section. And according to its name, it means for each household, how long can it remain homeless? How long can a household without a place to rent or to buy, without being an owner to a house or a renter, or person who rents a house? And interest per tick, this global variable will give its value to be interest rates divided by ticks per year multiplied by 100. Not quite sure what exactly this variable is going to do. Not quite sure what exactly is the meaning of all this, but we do have a variable called interest rates in the interface and the ticks per year in the interface as well. At least we know how this value is calculated. And now we have the minimum price fraction. This variable is defined inside of the code section. Basically, it says for a house to be sold, if the price dropped below the median price, multiply this fraction, then the house will be demolished, will be sold, will be out of the market. So that is the price ratio for the house to be sold immediately. And we set this ratio to be 10%. So if the price drop below, if the drop of the price greater than 10% from the median price, then the house will be gone. So that's the initial globals. And now we can move on to defining, creating the world by creating different agents. First of all, we can paint the world to be color 57, something like a muddy green. So all the patches will be muddy green. And now we can start to create realtors and distribute the realtors around the world. So first we can set, we can give realtors some default shape, which is a cylinder. Looks like this. Okay, this is the realtors. We have 6 realtors. And then we define a local variable direction. And its value can be any value between 0 and 360, a random value. And now we can create realtors. Give this number of realtors, n realtors, we set to be 6, so 6 realtors being created. For each realtor, we make its color yellow, and we set its heading to be direction, to be the local variable we defined for the current single realtor we are creating at the moment. And then we make that realtor to jump to a position. To what position? We make it jump outward by a quarter of the length of the world. So the realtor started, the realtor was born in the middle of the universe. And now we make it jump. We set its heading, and then we make it jump along the heading. How long does we jump? We jump the quarter of the length of the world. That is the maximum value of the patch coordinates minus the minimum value of the patch coordinates and divided by 4. So that is a quarter of the length of the world. After the location is set, we can update the direction for heading for the next realtor to be used, because we create one realtor at a time. So we use the heading, and then we update the heading. The heading for the next realtor is updated using this formula. That is the current heading multiply 120 degree and then multiply plus 120 degree and then plus a random degree from 0 to 30. Okay, this is for the next realtor. But for the current realtor, we will set its size to be 3, which is big enough for us to see it. And then we will draw a circle around this realtor. And how big the circle should be? This global variable is used as the radius for the current realtor's territory. So this is the radius value. We use this radius to draw a circle around the realtor, and this circle area is the territory for this realtor. So this is how we create realtors and how we create the circles around this realtor. Later on, we will examine what exactly does this draw circle do. As we know, the model, even the setup, is very complex. So in order to make the program run faster, we can use this line of code, no display. This function asks the program do not update the views until everything finished. We update everything together. In this way, the program can run faster. So when we use this function, even when we put continuous to view everything in continuously, we will see no process. We will see everything at the end. That is because we use no display. Once we comment this out and we run it again, we see the process. So that's how the no display is used.